Good day, STEM students and math enthusiasts. It's another fun-filled and educational day for us as we learn parabola, definition and its equation. Here are our objectives for today. Do you know why satellite dish or the reflector on most flashlights are parabolic in shape? This will definitely help beams or radio signals to reflect inward onto a particular point. Parabolas, which are often used in engineering and physics, have many important applications. Hence, it is important for us to study them as they often appear in nature or anywhere around us. The reflection property of a parabola, which makes any ray traveling towards it and parallel to its axis, will bounce off and pass through the focus. This important concept has been used by satellite dishes to receive TV signals that we use in our homes. This is also the same concept useful in other objects such as heaters, automobile headlights, mirrors, lenses, and many others. Parabola is formed with a set of points in a plane such that the points forming the parabola have the same distance from a fixed point called focus and a fixed line called directrix. Aside from the focus and the directrix, there are other parts of a parabola. First is the vertex. It is the extreme point of a parabola, meaning it is the one at the lowest when the parabola opens upward, the highest point when the parabola opens downward, leftmost when the parabola opens to the right, and rightmost when the parabola is opening on the left. Axis of symmetry is the line that passes through the vertex and the focus and is perpendicular to the directrix. It divides the parabola into two parts that are mirror images of each other. A chord of a parabola is any line segment whose endpoints are on the parabola. A chord is a focal chord if it passes through the focus, and the focal chord is a latus rectum if it is parallel to the directrix or perpendicular to the axis of symmetry. Before we discuss the equation of a parabola, there is another concept that will be very important in the discussion of this topic, and that is the focal length. Focal length is the distance between the focus and the vertex measured along the axis of symmetry. It can also be the measure from the vertex to the point on the directrix that passes through the axis of symmetry. Others would use A or C, but for this class, we'll stick to P. Now, depending on the position or the opening of the parabola, we may have a different equation. Let us first analyze the equations of parabola with vertex at the origin. But to do that, it is important to note that parabolas can be vertical or horizontal. If the parabola is vertical, it opens upward or downward and has vertical axis of symmetry. A vertical parabola has an equation x squared equals 4py in standard form. Its focus, if its vertex is at 0, 0 or the origin, has coordinates 0, p. Again, take note that p is our focal length. The equation of our directrix is y equals negative p, while the axis of symmetry is x equals 0 or the y-axis. Let us try to understand some properties of the parts of parabola. Take note, the graphic image does not represent the actual graph of the parabola with the given measures. The image is for representation only. If its vertex is at the origin, and its focus is 2 units above the vertex with coordinates 0, 2. It means that the focal length of the parabola is 2. The equation of the directrix is y equals -2. It is also 2 units away from the vertex, while the axis of symmetry is x equals 0, or the y-axis. Now what is the equation of this parabola in standard form? Using x squared equals 4py with p equals 2, its standard form of the equation is x squared equals 4 times 2 times y, which is x squared equals 8y. Note that a parabola that opens upward has a positive p, while a parabola that opens downward has a negative p. So finding for its equation, we have x squared equals -8y. A parabola that opens to the right or to the left is called horizontal parabola. It also has a horizontal axis of symmetry. The standard form of a horizontal parabola is y squared equals 4px, where p is the focal length and it is positive when the parabola opens to the right, while negative if it opens to the left. Its focus is at p0, while the directrix has equation x equals -p, and the axis of symmetry is y equals 0, or the x-axis. For this example, again, the figure shaped as parabola does not represent the actual graph of a parabola with the given measures. Suppose that the vertex is at the origin and its focus is at 2, 0. Then its directrix has equation x equals -2, and the axis of symmetry is the x-axis, or y equals 0. What's the equation? Using the standard form of equation of a horizontal parabola, that is y squared equals 4px, and the focal length p, which is 2, we can say that the equation of this parabola is y squared equals 8x. While this parabola that is opening to the left has a standard form of equation of y squared equals -8x. It would be easy for us if all parabolas have vertices at the origin. However, that is not the case all the time. If we are to translate this parabola whose vertex is at the origin to a parabola whose vertex is at 2, -3, observe what happens to the focus. You still add p to the y-coordinate of the vertex to get the y-coordinate of the focus. We just copy the x-coordinate of the vertex, just like what we did with previous parabola whose vertex is at the origin. The directrix is taken by subtracting the same value of p to the y-coordinate of the vertex. The axis of symmetry is taken from the x-coordinate of the vertex since it must pass through it. Again, it is similar to what we did with the vertical parabola whose vertex is at the origin. Going back to the equation of vertical parabola whose vertex is at 0, 0, it can be said that its standard form of equation came from x minus 0 squared equals 4p y minus 0, which when simplified is x squared equals 4py. This is because the standard form of equation of any vertical parabola is x minus h squared equals 4p y minus k, while for any horizontal parabola, the standard form of equation is y minus k squared equals 4p x minus h. Now let us try practicing what we've learned using the given on the screen. Find the vertex, focus, directrix, and axis of symmetry given the equation quantity y minus 4 squared equals negative 10 quantity x plus 3 halves. Looking at our given equation, it constitutes the standard form of equation of a horizontal parabola. And since our 4p is negative, then it must open to the left. From y minus k squared equals 4p x minus h, the vertex is hk. With this example, the vertex would be at point negative 3 halves 4. From here, we can already identify its axis of symmetry. The axis of symmetry of a horizontal parabola is also a horizontal line that passes through our vertex. If our vertex is plotted on a Cartesian plane, it would be placed here. Therefore, our axis of symmetry will be this line at y equals 4. Now to find the focus and the directrix, we will need the value of p that we will add or subtract respectively to the x-coordinate of the vertex. Since 4p is equal to negative 10, applying the mathematical solutions, we will have p equals negative 5 halves. Now to find the coordinates of focus, we will add this value to the x-coordinate and just copy the y-coordinate. And since negative 5 halves plus negative 3 halves is equal to negative 8 halves or negative 4, then the coordinates of our focus is negative 4, 4. To check, after plotting it to the Cartesian plane, it must be to the left of our vertex and pass through by our axis of symmetry. Lastly, the equation of the directrix is taken by subtracting this value of p still to the x-coordinate of the vertex so that it would be x equals negative 3 halves minus negative 5 halves would be 2 over 2 or 1. Hence, our equation is x equals 1 and it is also p units away from our vertex. And that's how you solve parts of parabola given a standard equation. Now let us try another example. This time, I'll be teaching you a pattern that we saw from the previous discussion. That way, we won't be needing to rely on graphing the parabola. Let's say, for example, we are asked to find the vertex, focus, directrix, and axis of symmetry for the parabola with an equation x squared minus 6x minus 2y plus 3 equals 0. This equation is expressed in general form. We need to express this first into a standard form so we can easily find the vertex of this given parabola. Arrange first the equation so that the terms with variable x, the variable that is squared, are on the left side, while other terms are on the right side. By completing the square, so that we will have a perfect square trinomial here, we can get x squared minus 6x plus 9 equals 2y minus 3 plus 9, which will give us a square of binomial x minus 3 squared equals 2y plus 6. Factor out 2, we will have 2 times y plus 3. This is now our standard form of equation. Now that our equation is expressed in standard form, identifying the vertex would be easy. But first, let us identify where this parabola opens. Now this is where I will be teaching you the pattern that I mentioned before. Remember, when finding the opening of the parabola, if the x variable is squared, then it must open upward or downward, or the parabola is vertical. If y is squared, then it must be horizontal. That means, from the general equation alone, we can already identify that this is an equation of a vertical parabola. And from our standard form of equation, this coefficient here is positive, meaning our parabola opens upward. Now for the vertex of this equation in standard form, we can identify it here that it is at 3, negative 3. Since from our standard form of equation, this is our h and this is our k. For the axis of symmetry, we can look at the variable that is squared as a pattern for the equation, whether it is x equals c or y equals c. In this case, since the variable x is squared, then the equation must be x equals c, where c is the coordinate of the vertex with respect to x-axis. Hence, our axis of symmetry is x equals 3. If in another situation, y is squared, then our axis of symmetry is in the form of y equals c, and c is the coordinate of the vertex with respect to y-axis. So without plotting our vertex on the Cartesian plane, we were able to identify the equation of the axis of symmetry. As for the focus and the directrix, where do you think will we add or subtract the value of p respectively? Is it in the x-coordinate or y-coordinate of our vertex? The pattern tells us that the value of p must be added or subtracted with respect to the variable that is not squared. In this case, it's the y coordinate. Let us solve first the value of p which will give us 1/2, then add it to y coordinate so that our focus is 3 -5/2. Then, directrix again is an equation in a form of y, since it is the one not squared, equals the difference between -3 and the value of p, which is -7/2. With that pattern, we were able to find the parts of the parabola without plotting them on a Cartesian plane. Let us try that pattern for one last time. Find the vertex, focus, directrix, and axis of symmetry given the equation 3y squared plus 8x plus 24y plus 40 equals 0. Again, this is an equation in general form, so we must express it in standard form first. Arrange the equation so that all the terms with variable y, the variable that is squared, is on the left side, while all other terms are on the right side. Before completing the square, make sure that the coefficient of y squared is 1. Then proceed with completing the square. Express this in a square of binomial that is y plus 4 squared, and simplify the right side of the equation. -40/3 plus 16 is +8/3. Factoring -8/3 on this side of the equation will give us the standard form y plus 4 squared equals -8/3 times x minus 1. With our equation in standard form, we can determine that this parabola is horizontal and it opens to the left. Since this is negative, let's now use again the pattern that we learned to find the parts of the parabola. For vertex, we have h and k, hence the vertex is at 1, -4. The axis of symmetry must follow the variable that is squared, hence the equation is y equals the y coordinate of the vertex, since it must touch that point. Therefore, the equation is y equals -4. Our focus and directrix will be solved after finding the value of p and adding it with respect to the variable not squared. Hence, that is the x-coordinate of our vertex. So to solve for p, we have 4p equals negative 8 over 3 until we get p equals negative 2 over 3. As I mentioned earlier, we will add this to the x-coordinate so that we'll have 1/3, then copy the y-coordinate, negative 4. As for the directrix, it follows the equation with respect to the variable not squared. Hence, it is x equals the x-coordinate of the vertex 1 minus negative 2/3 or 5 over 3. And that's it. That is how you find the vertex, focus, directrix, and the axis of symmetry given the equation of a parabola. Now let us try applying it to real-life situations. A satellite dish is 24 feet in diameter at its opening and 4 feet deep in its center. Where should the receiver be placed? In this problem, a satellite dish has a parabolic surface. If you will look at it from the top view, you'll see a circle with a diameter of 24 feet. Meaning, that is how wide the opening of our parabola is. On its side view, we'll see that its depth is 4 feet. Finding the receiver of the satellite dish means that we are supposed to find the focus of a parabola. It would be better if we illustrate the given in the problem and plot them in the Cartesian plane. Place the center of our satellite dish on the origin so that it would represent the vertex of the parabola. We can also let the opening of our parabola upward so that we would only be using the equation x squared equals 4py. Analyzing further our given, we can illustrate them using the coordinates negative 12, 4, and positive 12, 4. This will give us 24 feet for the opening of the parabola and 4 feet for the depth of the parabola. Remember that these points are points on a parabola, meaning they are represented by the x and y values. And since our equation is x squared equals 4py, we have to find the focal length p in order to determine how far away our receiver would be from the center of the dish. We can choose one from any of these 2 points to substitute on our equation. Let's say x is 12 and y is 4. We will have 12 squared equals 4p times 4. Simplifying this, we have 144 equals 16p, and p will be 9. Hence, the receiver should be 9 feet above the vertex. This is where we should place the receiver of this satellite dish. For this problem, let us again illustrate it on a Cartesian plane to better understand what we're supposed to find. We have two towers that are 170 meters above the bridge and 1,200 meters apart. We can illustrate the given using the coordinates -600, 170, and 600, 170. 170 represents the height of the towers, while -600 and 600 will give us 1,200 as the distance of the two towers from each other. The cable hangs following the shape of the parabola with its lowest point 20 meters above the bridge. So we can plot it here with coordinates 0, 20 that will represent the vertex of our parabola, since it's the lowest point of the cable that hangs in a parabolic shape. Now what we are asked to find in this problem is the height of the cable where it is 120 meters away from any of the towers. Since they are symmetrical, in the Cartesian plane, it would be this point here that is 120 meters away from the tower on the right, or this point here that is also 120 meters away from the tower on the left. The coordinates of this point are 600 minus 120 or 480 and y, which is what we're looking for as the height of this point on the cable. After illustrating our problem, we have to determine our equation first. Our vertex is at 0, 20. Then, we will use the equation x squared equals 4p y minus 20. We can't use this point yet to solve for y because then we will have two unknown variables, the p and the y variable. To solve for p, we can use either this point or this point. Substituting our equation, we have 600 squared equals 4p 170 minus 20. Simplifying, we will have 360,000 equals 4p times 150 600p. Simplifying, we have p equals 600. Now with the value of p and x earlier, we can now solve for y. Using the same equation, substituting x with 480, we have 480 squared equals P is 600, so we have 4 times 600 times Y minus 20. 480 squared is 230,400, which is equal to 2,400 times Y minus 2,400 times negative 20 is negative 48,000. Simplifying this, we'll have Y equals 116. Therefore, the height of a cable, where it is 120 meters away from the tower, is 116 meters. How about you try solving for this problem your own to practice further your skills? You can pause the video at this point so you can try it yourself and check your answer if we're the same. And that's it for Parabolas. Tune in next time for more math lessons. You may like or share this video if it helped you a lot. Or click the subscribe button and the bell so you won't miss more of our future lessons. Thank you so much for watching. Goodbye, class!